Hello friends, I Professor Bhavik Kumar M. Kataria welcomes you into the video series of operating system, and we are discussing unit number 2, process management. In our earlier session we have discussed process states and state transition diagram. So guys, if you are still remain to watch that video of state transition diagram, then you can click on I button at top right corner and you can watch that video and come back here to understand today's session about process scheduling and types of scheduling. So let's start today's session, process and CPU scheduling. First, we will discuss parameters of process. First parameter, that is arrival time. As per we have discussed in state transition diagram, whenever process is arriving into the ready state and processes are ready to execute. So on which time process arrived into the ready state, that time is known as arrival time. Second thing, burst time. It means how much time process will in execution. As per our discussion, there are different types of states like waiting states, running state, termination state. So whatever the time process is spending inside the run state, that time is known as a burst time. Second thing, completion time. So after the completion of execution, process should terminated. So on which time process is going to be terminated, that time is known as a completion time. Then after turnaround time, it means this time is known as a total journey time of process. Whenever process will start their execution, it means process will reach into the ready state and process started their execution. And after few time of execution, suppose process will go to the waiting state and again from waiting state to process will reach into the ready state and second time start their execution. So this whole timing cover under the turnaround time. It is known as a completion time minus arrival time. So whenever we want to measure turnaround time, so we can subtract arrival time from the completion time, so we can get the turnaround time. Or other thing, if we have a burst time and waiting time, so we can do the summation of burst time and waiting time and we can get the turnaround time. Next thing, that is waiting time. It means out of the total turnaround time, whenever we will subtract the burst time, so we will get the waiting time. If we will implement the formula by this equation, if we will make waiting time, so we can subtract burst time from the turnaround time. It means during this time process was in waiting. It means process are not in running state. Process is waiting for the some other resources look like input output devices or any other thing. Then after response time, whenever process will arrive into the ready state, so it is not necessary all of the process will start their execution. Out of a few process among the ready state, any one process will get the CPU and that process will start their execution if there is a single processor system. Get it? So whatever the process will get the CPU first time, that time is known as a response time. Look like you are doing a message to someone like your friends. You are sending a message to your friends, hi, hello, good morning. So suppose maybe that person is not online or that person will be busy in another work. So whenever that person is replying to you, yeah, very good morning. So that is a response. Same thing after reaching into the ready state, whenever process will get CPU first time, that time is known as a response time. If we will try to understand another examples like in non-technical terms, suppose you will consider the example of train. So whenever you will go to the railway station, so you will get two times. One is arrival time and second one is departure time. Like train is arriving at 6 a.m. and departure time is 6:02 a.m. It means 6 a.m. and 2 minutes. So that is a departure time. But whenever train is arriving on platform, that time is known as a arrival time. Same thing for the process. Burst time. It means how much time process is in execution. Look like if we will compare with the turnaround time. Suppose you are traveling from Ahmedabad to Mumbai and total journey time is 8 hours. So it is not necessary total 8 hours train is spending during their running moment. Maybe a few holes are there in between the journey. Get it? If we will compare to the bus, so somewhere bus is waiting at a toll booth, waiting on traffic. Same thing, train is waiting whenever train is not getting a signal. So this time is known as a waiting time, and total journey time is known as a turnaround time. And whatever the actual journey time, this thing is known as a bus time. Same thing for the completion type. Like a train is starting their journey at 6 a.m. from the Ahmedabad, and after 8 hours 2 p.m. train is going to reach at Mumbai. So 2 p.m. is known as a completion time. Same thing in case of process. Whenever process will complete their execution, that time is known as a completion time. Let's discuss few types of scheduler. Total there are three types of schedulers, that is long-term scheduler, medium-term scheduler and short-term scheduler. We will discuss all three schedulers one by one. First we will discuss long-term scheduler. So if we will look into state transition diagram, so whenever a process are arriving from new state to ready state, so that responsibility is on shoulder of the long-term scheduler. Long-term scheduler is responsible to schedule the process from new state to ready state. Another thing, that is a medium-term scheduler. So whenever processes are in ready state and waiting for the CPU, so short-term scheduler will call to the dispatcher and dispatcher will allocate CPU to the process which is ready to execute. So that is the responsibility of short-term scheduler. Then after medium-term scheduler, if we will discuss about the medium-term scheduler, so whenever processes are in waiting state or block state and lack of the memories inside the primary memory, if operating system is going to suspend that process and putting it into the suspended wait, so this thing is carried out by the medium-term scheduler. So this thing is all about long-term scheduler, short-term scheduler and medium-term scheduler. Next, we will discuss few terms related to scheduling. That is degree of multiprogramming, context switching and swapping. First, we will discuss about the degree of multiprogramming. So whenever long-term scheduler is bringing any process from new state to ready state, so this thing is known as a degree of multiprogramming, because multiple process are ready to execute, and same thing into the secondary memory there are a lot of programs are going to be stored. Out of those programs, long-term scheduler is going to select that program which program is require the execution, and that program will become a process. So this thing is known as a degree of multiprogramming. Next, that is a context switching. Whenever process is in run state, so look like if any higher priority process will arrive, so operating system will suspend to the current process or put it into the waiting state and execute higher priority process. Or look like willingly any process is going for the input output devices and that process is going to left the CPU, so CPU is allocated to some another process. So this thing is known as a context switching. It means CPU is allocated to from one process to another process. This type of switching is known as a context switching. Third term we will discuss, that is swapping. Whenever processes are going from waiting state to suspended wait, it means whenever medium term scheduler is placing a process from waiting state to suspended wait, it means processes are going from primary memory to secondary memory, and again whenever processes are going to resume, so processes are arriving from secondary memory to primary memory. This thing is known as a swapping of process. Then after we will discuss few scheduling algorithms in our earlier next video, that is first come first serve scheduling, shortest stop first scheduling, priority scheduling and round robin scheduling algorithm. So we will discuss all this algorithm one by one. In our next session, we will discuss first come first serve scheduling.